Hi everyone, I'm back. Today we're going to look at 8.9, section 8.9 of the textbook. If you happen to have brought that home from before March break, you can also do some extra readings there. 8.9, observing celestial objects from space. So celestial objects are any object that is out in space, and they are visible from Earth both day and night. The ecliptic. This is the path across the sky that the sun, moon, planets, and other signs of the zodiac appear to follow over the course of a year. And I do want to emphasize that word appear. So we know that the moon definitely moves, planets definitely orbit as well, but we do know that the sun and the signs of the zodiac, which are constellations made up of other stars, the sun and those stars do not move, but they appear to move. So just like the sun appears to rise in the east in the morning, travel over top of us, and set in the west, uh, the stars in the sky appear to move as well. And due to our rotation of west to east, things appear to move east to west. So the changing views of the night sky. Our Earth's rotation from west to east causes objects in the night sky appear to move from east to west. Now, the distance an object is from Earth affects how it's observed. So planets are much closer to the stars, their paths often change with respect to constellations. And the night sky changes with each passing season due to the Earth moving around the sun. So some stars that are over top of us, directly up over top of us, they tend to be visible all year round. Other stars that are closer to the horizon tend to dip in and out of our viewpoint depending on the month of the season, and that's based to where we are on our orbit and our tilt of the Earth in respect or relation to them. Kind of a neat thing, retrograde motion. So stars don't move, but they appear to move because in relation to the Earth because we are moving. Other planets do move. We know that they are in orbit around the sun. And so retrograde motion, this is kind of a neat phenomenon where a planet is moving in the opposite direction. So sometimes it looks like a planet is moving from west to east, which is how it normally appears to move to us. And then all of a sudden it'll be as if that planet stops and then starts going the other way. And this is all, it obviously hasn't stopped and turned around and started going the other way, but appears to have based on its relative position to other things in space, namely the stars. So click on this link here and you can go over it a couple times and you can actually see uh, what the motion is like, the retrograde motion. So navigating the sky. Due to the Earth's rotation around the sun, we see different constellations in the sky at different times of year. And the constellation we see also depends on our latitude. So in the northern hemisphere, we see a bunch of different constellations than they do in the southern hemisphere. And as I've already previously mentioned, some of the constellations that are near the horizon tend to slip below the horizon at different times of year, so we can't see them. The way that we describe the position of constellations or celestial objects is we use azimuth and altitude. So azimuth is the distance measured from north along the horizon, pointing directly below a celestial object. So if I'm facing north, and this star that I want to look at, if I start rotating toward the east, and I turn myself 90 degrees, and now I'm looking in that star, that would be my azimuth. That star would be 90 degrees azimuth to me facing north. And then there's the altitude, and this is how high up in the sky it is. So this is based on an angle. If that star is just above the horizon, it might only be a 10-degree altitude. If it is right above me, it would be a 90-degree altitude. So you can see here in this diagram, if I am standing right here at the start of this sight arrow, and I am looking north. If I want to describe where this star is, I would first travel along the azimuth path. And in this case, I'm not quite looking east yet. This might be 60 degrees azimuth. So I've just turned 60 degrees from facing north. And then if that star appeared right here at the horizon, it might be only a degree or two altitude. But as I have to tilt my head upwards to look at it, we can see here that this star might have a 35-40 degree altitude. So 60 degrees azimuth from north, and then let's say 40 degrees altitude, and I would be looking right at that star. Now, one thing that does affect our view of the night sky is light pollution. That's right, pollution, or light can actually cause pollution. I know when I go to my backyard here in the city, I can see some of the brighter stars, but I definitely can't see all of them. Hopefully you've all had the experience of going to a cottage or a trailer or camping or out to a farm and been able to look up at the sky at the nighttime from a rural area where there's no light pollution, and it seems like the stars are endless. It's like somebody's taken a piece of black construction paper and sprinkled sugar all over it. There's just so many more stars become visible when we get away from the light pollution. And that's it for today, ladies and gentlemen. Have a great day.